I'm Johann. I'm from the University of Hamburg, and I'm currently writing my master's thesis on HPC and Docker. So, I have this talk structured in two big parts. First of all, I will show with two small examples how I think Docker can be used for software, for HPC software development. And then in the second part, I will show what I'm currently working on, so it's a work in progress. And I will show what problems emerge if you try to move this development process from a local machine into a production environment. Okay, so normally Docker is used for configuration management, deployment, continuous integration, delivery. And you can use this configuration management and deployment part to quickly deploy HPC applications because they're time-consuming to set up, to port. You have to wait on resources on your cluster, and you have a long test and modify cycle. By the way, I will fly through the first part so we can have a Q&A session on the second part, since there was some interest. So, Docker as a local development environment. You can use the configuration management aspect of Docker to have an environment set up that can build, run, and test an application. So you have just a single image and a single container. And the interesting part or a little trick I'm doing is I add a user to the Docker image, just a build user, give it a work dir, and then when I start the Docker container, it gets a user mod for a certain UID and switches the user into the build user. So to solve this problem, when you're running a Docker container and you want to access your files on your local machine, you just set your current UID to the UID of the build user, and you can access all your files without any conflicts. So let's have a little live demo. So here's the Docker run commando for it. It's just that it runs interactive. And I'm mounting the current working dir as the working dir of the build user. I'm passing over my UID to get read and write permissions to the files. And I'm running the Docker container. In this case, it's called buildbox. So I run it. I get access to the work dir, and I have a hello world C. This is inside my Docker container, and I can run gcc hello C, execute it, and I have compiled a little program in my Docker container. This is not fancy, but this one is my local machine. And here is the C file from the Docker container above. I just compiled, and now I can edit it if I want to. Just add another O to it, right quit it, go back inside my container, recompile it, and the output changed. So I have working in development environment in my container, and I can change my files on my local machine, which just means I can use a graphical IDE with tab completion with all the fancy features I want, and test and run it inside a pre-configured Docker container.
Maybe Johann, just to make sure everyone is up to speed, what he's doing and what we are talking about. So by changing the UID of the user inside of the Docker container, he's tampering with his files in his home directory with his own UID. So if you start the container with UID equals 500 or something, so just to check, if you're in the above, just to show the difference.
So now if I want to...
If you compile it and then illustrate that ls minus l is a different UID then.
So, and now it's run against a different UID. The permission changed from 1,000 to 10,000.
Okay. So you can use Atom or whatever preferred editor you have on your Mac or what have you, and then compile it within a certified or within an environment that everyone is using, And then you have the same result for all developers by using your own fancy editor like Emacs or Vim or Atom or whatever, right? Okay.
So, and I can increase this. I can use it for HPC applications. So now I'm using the configuration management aspect and the deployment aspect and run a single or multiple image setup inside multiple containers. So the image layout I'm running is just a base image which provides a basic Slurm setup, and the next layer of the image provides a compute image with the dependencies like MPI, HDF5, NetCDF, and everything else you need. So I use Docker Compose for this. What will happen now? I will start up 5 containers, 1 login node, 4 compute nodes, and again, the set UID will happen on every container, and the working directory will be mounted inside every container. So Slurm finds the necessary executables inside every container, and Slurm can work with them. Let's see. Docker Compose up. Though the nodes and the login nodes gets created, I can docker exec login, jump into the container, switch my user over to the build user, and I'm inside the working dir. And here again, I can show as info I have 4 nodes idling. And I can run just a simple command. Nah, come on. Lupala host. Yeah. So I can run a simple command to make sure it's working. This is a running Slurm cluster on my laptop for development purposes. And now I can even run run MPI commands inside of it. Can everybody see this down here, or should I switch it up? Maybe I can. No, it's gone. I keep it like this. So I can run simple MPI commands inside of it. Nah. Clear? Yeah. Oh, come on. So now I can. I have WARF compiled for this, and I have WARF running inside this container, but the files are actually accessible from my host machine. So I can run WARF, modify it, recompile it inside the container, and then run it. EDL and it starts up and it's running. I will interrupt it so it doesn't take too much long time. So I have a local development cluster. I can set up any environment for any application I like. I can distribute this image to my fellow developers or to other people who just want to test this Docker image on the machine, and they can run it, get the application they want, unpack it, run the setup, compile it, and test it locally without having to compile a lot of libraries, dependencies. And if you maybe if you're not familiar with a certain program, you maybe need half a day or a day to set up your whole environment to get an HPC application up and running. So this saves you a lot of time.
So are you going to have these available actually somewhere where can people try that?
What do you mean?
Are you going to have this image or just this container available somewhere so people could try it?
Yes, I can make it available if you want to.
Yeah, definitely.
Okay, so.
I mean, just to jump in, And we are not talking about performance testing, right? So we are testing. We
are
talking about
functionality.
you're on the train. You have no internet, and you can just develop on your application and then compile it stuff. So it's very nice to train.
So it would be nice if we could use these images to just take them, throw them on our HPC production system, and run them, just in the way I run the container on my local setup. So just tell the scheduler, take this Docker container, run it, and run this application inside of it. This would be pretty nice. So in this case, I would have the application bundled inside of the actual Docker container. So I can just take the container, say run it, and it will be run on the production system. But there are multiple issues that emerge from this use case, and these are some of the problems my master thesis tries to solve. So, for example, we need proper scheduler integration. I'm working with Slurm, and so Slurm would be must be able to pull the image, to run the image, make the setup, make the network setup, make the I/O setup. If the container is done, stop it, gather the information, and remove the container. So this can be achieved through, for example, some sort of plugins. So Slurm knows how to handle these containers. Is there a question about this? No? So let's talk about security. If you're running a Docker container in your production system, the user who runs this Docker container is equivalent to root. So you maybe, or normally, you would only want to have trusted users execute your containers, or modify your containers, you would say. And all the images on a node are visible to all other users who have access to the Docker daemon. So, for example, if you have some, I don't know, private data, confidential data running some simulations you don't want everybody to see, everybody else on the node can look into your image. And so only make these Docker images accessible to trusted users, which in a big corporated environment is, well, not practical. So I came up with maybe 3 ideas to solve this issue for accessing the Docker daemon without the need of being a trusted user and using root. There are, like said before, there are you shouldn't be able to execute system commands or mount certain directories into your container. So, for example, you could say, I'm writing a custom Docker client who doesn't have these features, and it will run with setuid to make black clients or the official Docker client not able to run with the Docker socket. So when you execute it, you get maybe a different group ID, get access to the Docker socket, and you can run it. Second would be you're writing some sort of proxy software that filters out your run commands, checks for certain volumes to be mounted, ports to exposed. And you would have this proxy filter out these commands, deny the execution if you're violating some sort of rules. Or the third solution would be, which I think would be the best for everyone, if you modify the official Docker daemon and Docker client for make it possible to define some sort of security rules. So, who knows what Docker plugins are? Did anybody heard of them? Docker plugins at the moment exists for volumes and for network, I think. So a Docker plugin, for example, lets Docker talk to ZFS or GlusterFS. There's a plugin you can load, and Docker knows how to handle these file systems. This is called a volume plugin. So why don't make Docker able to write some sort of security plugin to enforce your own security rules on top of the Docker daemon and the Docker client. This is what I'm currently working on, and I'm currently trying to figure out how to do this in the best manner. I don't know, has any one of you, except from having one trusted user verifying all the images, has a different setup to secure their production environment, or thought about something like this? Not, yeah?
We have thought of several options. And, actually, we are going for the middle street in our solution.
Okay, so capability that Docker already has, and add security plugins to it. And if possible, it would be really nice if these changes could get merged upstream if they want to have it. So this is, as part of my master thesis, I try to get as many changes back to the community as I can, if they want to have them. So I'm opting for the third option, and I will see if I have any success with it. Any more questions about Docker security for the execution for the root users?
Why Docker requires to be root by design? Why cannot be like a Docker user that has a normal privilege, like any daemon that we can start in Linux and have special access to some system calls if required? Why not be root?
I think we are close to getting in a red hole, because security you can talk about security over ages. I mean, the Docker concept is you have a server which you say, okay, start this daemon, start this container, start this container. So you have a central agency, and this requires this daemon, right? But you have also run C or from the core team or core OS team, and they have this Docker or container system as a serverless version of it, where you just say, run a container, and you run the container out of your process that you're just invoking. You don't have a central server that starts and stops containers, which is maybe more applicable to HPC, some HPC environments, I think. But as said, I mean, we can.
I think this is the functionality, but that doesn't answer anyway.
Yeah, but we should talk after the.
So I think.
Yeah.
I don't know. It's actually a good question, and I don't have given it so much thought. But I think one problem would be Docker containers are allowed to do a wide variety of actions. So you would have to give the user who runs the Docker daemon access to all these specific system calls, like mounting file systems, doing exposing ports, and doing the whole network setup. So the problem is, if you give a user all these access rights, that he actually needs to set up a Docker container inside a HPC environment. Maybe there's some way to break out of it, or there are so much rights that it doesn't make a huge difference. So I will look into this. It's a good idea, but I would think having filter mechanisms to filter out certain options or cut not to missing the word to restrict. Thank you. To restrict the way in which they work would be sensible, but I will look into it. Thank you. So then another point I think about is reproducibility. Docker is really nice in this point, because you can export the image to disk with just a simple command line. You just say Docker export contain the running container. I can gzip it, and it's on your disk, and you can re-import it and rerun it. And if you want to persist your changes, you can just take the file, export it to tape or store it in your data archive. And if somebody asks you, hey, can you show me how you produced these results? You just say, here, you have the exported Docker image, import it, have a look at it, and you will see how I did it. Is anybody working on reproducibility with Docker? So, so do you have any reports you can give, or how you work with it? Well, are there some problems?
Actually, we'll talk about it.
Okay. So we will get to it. Nice. Okay. So are there any more questions? Yeah.
So going back to the security slide, I don't want to go. I'm not going to go down the rabbit hole. So for the middle route that you have laid out there,
Yeah.
I was just curious to know what you have in mind, the security proxy that's going to happen, the security checks that are going to happen. Will it happen at the Docker file level or at the Docker image level?
This is
check exactly?
This is the first checks. This setup is for the actual execution of the run. This will be first runtime checks. Then the next step would be to add statistical analysis to the Docker files to disallow certain actions.
I think next year we might opt for a longer workshop to have all these different approaches. I mean, we can fill a whole week with it, I think.
So, any more questions? And